Welcome back in lecture series on topic electrochemistry. In last video, we have studied what is meant by conductivity cell, how cell constant is determined, and from cell constant, how to calculate conductivity and molar conductivity of electrolyte solution. And today in this lecture, we will solve numerical problems based on cell constant, conductivity of the solution and molar conductivity of electrolyte solution. So let us see numerical problem, but before going to start, first we will see the important formulas which you have to remember. First formula, that is cell constant, that is equal to L by A, ratio of distance between the two electrode and area of cross section of the electrode is nothing but cell constant, and its unit is, in SI unit, its unit is meter inverse and common unit is centimeter inverse. So remember that cell constant is expressed in centimeter inverse. Second, that is if you know the resistance, if you measure the resistance of the solution using conductivity cell, and if you know the conductivity of standard solution, then you can calculate cell constant if you do not know the distance and area. So second, that is cell constant is equal to conductivity of this electrolyte solution, standard electrolyte solution, into the resistance of that solution. That will give you the cell constant. And third important formula, that is the conductivity is equal to cell constant divided by resistance of the solution, and it is unit of this is ohm inverse centimeter inverse. And if you know the conductivity, then from that you can calculate molar conductivity of the solution, and that is equal to 1000 into A divided by C, and its unit is ohm inverse centimeter square mole inverse. So let us see one simple problem based on this. That is, the distance between the electrode of conductivity cell is 0.98 centimeter and area of cross section of electrode is 1.3 centimeter square. Calculate cell constant for the cell. Very simple problem. What is given? L is given 0.98 centimeter. A is given, that is 1.3 centimeter square. So you can use the formula cell constant is equal to L by A. So cell constant is equal to 0.98 centimeter divided by 1.3 centimeter square. If you solve this by log, then log of 0.98 minus log of 1.3, and log of 0.98 is bar 1.9912, and log of 1.3 is 0.1139. So if you subtract this, then you will get what? Bar 1.8773. Antilog of 0.8773 is 7539. Characteristic is bar 1. So you have to put the decimal point here before 7. So 0.7539. So the answer is cell constant is 0.7539 centimeter inverse. Unit of cell constant is centimeter inverse. So such a type of a problem may be asked in short answer type question or in MCQ. So remember this formula. Then next, that is conductivity cell containing 0.01 molar KCl gives at 25 degrees Celsius the resistance of 604 ohms. The same cell containing 0.001 molar AgNO3 gives resistance 6533 ohms. Calculate the molar conductivity of 0.001 molar AgNO3. Conductivity of 0.01 molar KCl at 25 degrees Celsius is 0.00141 ohm inverse centimeter inverse. Now what is given in this example? Resistance of KCl solution is given. That is resistance of 0.01 molar KCl solution is how much? 604 ohms. And concentration of AgNO3 is given, that is 0.001 molar AgNO3. Resistance of AgNO3 is also given, and that is 6533 ohm. And conductivity of standard KCl solution is given, and that is 0.00141 ohm inverse centimeter inverse. Now what you have to calculate? Molar conductivity you have to calculate. Calculate molar conductivity of the solution having concentration 0. Here 10 must be there. 0.00 molar AgNO3 solution. And therefore required formula, that is cell constant is equal to conductivity of KCl into resistance of the solution, and from that you can calculate conductivity is equal to cell constant divided by R. Using this formula you can calculate conductivity, and from that you can calculate molar conductivity, that is 1000 into K divided by C. So first we will calculate cell constant. So resistance of KCl is 604 ohms and conductivity of KCl is 0.00141 ohm inverse centimeter inverse. So if you substitute these values in this formula, you will get what? The 0.00141 into 604. Now if you solve it by log, taking the logs of these two, that is log of 0.00141 plus log of 604, and that is equal to log of 0.00141 is bar 3.1492 and plus log of 604 is 2.7810. So if you add these two, then you will get what? Bar 1.9302. So antilog of 0.9302 is 8515. As here the characteristic is bar 1, you have to write this decimal point here, and therefore 0.8515 is your answer. So cell constant is equal to 0.8515, unit is centimeter inverse. Now from cell constant you can calculate conductivity. So conductivity is equal to cell constant divided by R. So cell constant is 0.8515 centimeter inverse. And resistance of AgNO3 is given, that is 6533 ohm. And the same cell is used for the measurement of resistance of the solution. Same conductivity cell. So cell constant is same, it will not change. So using this cell constant value, we can calculate conductivity of AgNO3 solution having concentration 0.001 molar. So here, if you take log of these two, that is 0.8515 minus log of 6533, then log of 8515 is same, that is bar 1.9302 minus log of 6533 is 3.8149. So this subtraction is bar 4.1153, and antilog of 0.1153 is the 1304, but here the characteristic is bar 4. So you have to write the decimal point here. So 0.0001304. So conductivity is equal to, conductivity of AgNO3 is equal to 0.000130 ohm inverse centimeter inverse. So it is nothing but 1.304 into 10 raised to here minus 4 ohm inverse centimeter inverse. Now from conductivity you can calculate the molar conductivity of AgNO3 solution having concentration 0.001 molar. So lambda is equal to 1000 into K divided by C. So conductivity is 1.304 into 10 raised to minus 4. Concentration is 0.001 molar. So using these values, substituting these values in this equation formula, lambda AgNO3, lambda of AgNO3, that means molar conductivity of AgNO3 at concentration 001 molar is equal to 1000 into 1.304 into 10 raised to minus 4 divided by the concentration, that is 0.001, and that is equal to how much? 1000 means 10 raised to 3 into 1.304 into 10 raised to minus 4, and here 0.001 means 10 raised to minus 3. When it comes on here, then it is 10 raised to 3, and therefore it is equal to how much? 1.304 into 10 raised to minus 4 into 10 raised to 6, and that is equal to 10 raised to 2. 1.304 into 10 raised to 2, and therefore it is equal to how much? Lambda, that is molar conductivity of AgNO3, is equal to 130.4 ohm inverse centimeter square mole inverse. So such a type of a problem may be asked for 3 marks, because here you have to calculate cell constant, conductivity and molar conductivity. So like this you have to prepare. Thank you.